Hi everyone, I am Sumida Puhami, ICT teacher, Marshalla College, Nigambu. Today we are going to discuss about the operating system lesson. What is a file and file allocation methods? This subject area requested by many students. So I thought of discussing all the things with the help of this presentation. I have used some resources I have taken from the internet. Mainly the ICT syllabus guide, teacher's manual available on the internet. First we have to think about a file. A file is a named collection of related information, usually a sequence of bytes. A file can be viewed in two different ways, logical way and the physical way. So you all know what is a file. You all have seen and you all have done many functions with the file. How you can read the file, how you can write the file, how you can delete the file, how you can rename the file. Like that, many operations you have done with the file. Can you remember we have done Python with the help of the Python programming language, how we have used the files. So just remind that. So here basically they have mentioned a file is named collection of related information, usually a sequence of bytes. Okay, right? So when you consider about a file, it has a name, it has a capacity, and it has a type. Like that, many things are there. So in detail we will discuss about that. So the file we can access like logical view. It has two different ways, logical view and the physical view. What is logical view? Logical view means how the programmer see, how the user see this file. Linear collection of records, image file, it's a combinations of cells like pixels, then a linear sequence of bytes. Physical operating system, how the operating system see a file. Okay, so this is the main area that we are going to discuss. How the file is stored on secondary storage. So normally we are using a file to store something. So that means permanently. If you are storing something permanently, we have to use the secondary storage. When you are storing in the secondary storage, that means the disk, we have to discuss about the sectors and the clusters. The smallest location we create in the computer, disks, are sectors. When you are formatting, you are creating the sectors. But after you created this thing, you have to create a cluster. Cluster is a collection of sectors. Cluster is the method that the operating system used to access a file. A part of a file can be there. So it is a kind of block. Cluster is a block. It has a collection of sectors. So we will discuss that thing in detail. Now, when you consider about the file, first you have to know the attributes related to the file. So when you consider a file, each file has the associated collection of information, attributes, file name, type, owner, location, organization. So how you are going to store the file, access permission, to who can access this file, who can edit the file, who can delete the file, who can read the file, and who can read and write. So like that, access permission, time and date creation, modification, last access, and the file size. So these things you all have seen, right? When you right click on the file, I'll show you. So here I have taken a file. So this file is ICT syllabus teacher's guide. So what I have done, I have right click on the file and I have taken the ICT properties. So when we have taken the properties of this file, this is a PDF file, .pdf. So that means with the help of Adobe Reader software, we can read this file. So this is the file name. And this is the location where we have stored this file in the secondary memory. /2019 new syllabus and notes. So this is the folder. Inside this folder I have stored this file. What is the size? 4.92 MB. So they have given number of bytes here. Size on disk. So here the size and here size on disk. What is the difference between these two? We will discuss. Created, when we have created this one. Modified, when we have done the modification. Accessed, first time when we have accessed this one. Okay, so here the date and times are. Attributes. So what are the attributes available? Read only, hidden. So we are having a button called advanced. We'll see how we can use that. Security. The file came from another computer and might be blocked to help to protect your computer. Sometimes with the files, malwares can be downloaded into our computer. To protect that, they have done a security measure, and if I want, I can unblock this. Okay, so these are the main attributes given in the general tab about the file. So I have given here, files are stored on the disk in what is called clusters. The main file sticker, it has stored in the disk where in the clusters, a group of disk sectors, collection of sectors we can call as cluster. So later we are discussing, we are giving the name for cluster block. So block means number of sectors, remember that. Size on the disk refers to the amount of clusters allocation a file is taking up compared to file size, which is an actual byte count. Now here you can see, again I have taken a file. The size is 463 kilobyte. The size on the disk is 464 kilobytes. So see how many number of bytes are differ from here. So here 463 is the file size and the size on the disk is 464. Two different capacities of the same file. So when you consider about the clusters, when you consider about the sectors, now the smallest location in the hard disk is sector 512 bytes. 512 bytes. So when you consider a cluster with two sectors, so that is 1 kilobyte. So 512 bytes plus 512 bytes, so that means 1024 bytes. So that is we are calling as 1 kilobyte. So just try to understand, a cluster is represented with two sectors. So the size of the cluster is what? Size of the block is what? 1 KB. Now you have 750 bytes file. So what will happen? When you have stored, it is not using the whole block, whole cluster. Some space, the space location are waste. So later we will calculate that. Just try to understand. So that is the difference between this size and size on the disk. So when you consider about the size on the disk, even though you have 750, you have used two sectors. So then 1024 bytes. Try to understand that. If you have any doubts, you have to ask from me. You can put a comment or you can email me. You know all the details about myself. So here I have taken the security tab. So you can see when you come to security, group or usernames, authenticated users, system, administrator, users. So you know your administrator means the main person who is controlling the system, and users means any person can use this computer, and we can give a username and the password for him or her. So they, with the help of their username and the password, they can access my files. But I can give the control. Now when you select the administrator, so the administrator has allowed to access this file fully. Full control is there, modified, read, write, and special permissions. So all the permissions I have tick here, allow, can do anything. But when you come to the user, what will happen? It has allowed to read and execute, and to read only. Only these 2 points have allowed. So that means this person who is using this file, grade 12 Teachers Guide ICT, can read and execute the file only. Can read and execute the file only. But the administrator can access and modify and whatever the things can perform, can do with that. Okay, we will move to the next one. Now when you consider about the details of the file, so here given file name, file type, folder path, size, date created, date modified, attributes, owner, and the computer name. So you can take the whole details. So these all the things are maintained by the operating system. For what purpose? To easily access whatever the files that is on the computer. Right? Mainly these details helps to read and write the files and do the modifications and giving the access rights and the full control of the file easily within the computer system. File types. So what are the file types? As we have discussed earlier, we have discussed about the PDF file. The PDF file, that is we are calling as the extension of the file. With the help of the Acrobat Reader software, we can read the PDF extension. If you want to type a letter, you can use Microsoft Word application. If you want to do any spreadsheet calculations, then you can use MS Excel. If you want to do a PowerPoint presentation, you can use Microsoft PowerPoint. Okay, if you want to type a text, just a text, you can use the Notepad. Okay, so like that, for each and every file, there's an application to run that. Now, here, I have given the file types. One of the possible implementation technique of the file type is to include the type as an extension to the file name. So you are having the file name dot the extension. File can be classified into various types based on the content. Based on the content, we can classify the files. So .exe, that means executable files. Now when you download software or any other thing, game or whatever thing, so you are downloading with the executable file format. Then you are executing that means installing that into the computer. Okay, so that is kind of exe. Then you are having text files, .txt, .docx, Microsoft Word file. Then image files are there, video files are there, audio files are there, compressed files are there, .rar, .zip. I think most of you all have used these things. So with the help of the extension, you can identify the file type. File structure. A file structure is a format that the operating system can understand. File structure, there must be a structure. Now when you go to your school, in the school you are having a hierarchy, structure, principal, vice principals, sectional heads, like that. So here also with the operating system there must be a structure to identify these files and to access these files and to do modifications. So the operating system uses the file structure. A file has a certain defined structure according to its type. A text file, as example we'll take a text file, is a sequence of characters organized into lines. So you can understand this thing now. Now if you want a text file, what you are doing, you are using number of characters, you are typing the characters. So these characters are represented in lines. Okay, that is kind of text file. So when you consider about the text file, you can like memorize how you are typing in the notepad, only the characters. So line by line you can type whatever things that you want. Now when you consider about image, you are using different cells, pixels. With the help of the pixels you can access the image. Okay, so when you are doing Photoshop or editing the images, you know how the pixels are moving. Okay, according to the pixels, if the number of pixels are high, you are getting good quality picture, image. Okay, if the number of pixels are less, the quality of the image will be low. An object file is a sequence of bytes organized into blocks that are understandable by the machine. So this each and every block must be understood by the machine. That means the operating system, then only you can take the whatever the necessary output. File systems. A file system is used to control how data is stored and retrieved. So normally a file system. So now you all know what is a file, what is a file type. Now you are going to discuss what is a file system. With the help of the file system, what you can do, you can store this file and you can retrieve whenever you require. Okay, so we have discussed the hard disk. In the hard disk, when you use the disk format, what will happen? It will create the tracks, sectors and other things. With the help of the operating system, you are creating the cluster, the block that you can access at once. Okay, now these files are stored and these files you have to retrieve whenever you require. So that is coming under file systems. FAT file, file allocation table. File allocation table. FAT is the file system introduced with Microsoft Disk operating system. FAT uses file allocation table to keep track of files in the storage device. So you need a table. With the help of this table you can identify the file name and where you have stored the file. So when the computer hard disk read write head move to file allocation table, it can identify where this file has stored and it can retrieve and it will transfer it to the main memory. Then you can see it on the screen. FAT and root directories reside at a fixed location of the volume so that the system's boot files can be correctly located. To protect a volume, 2 copies of FAT are kept. Now what will happen? Here the file allocation table and the root directory resides at the fixed location of the volume. Volume is the hard disk. Where now when you consider about the hard disk, after you format the hard disk, what you are doing, logically you are dividing this hard disk. C drive, D drive, I drive, right? Like that. You are giving some drive letters and logically you can identify that location. So when you consider about your operating system, master boot record or whatever the boot records and other things, so they are stored in a fixed location where the hard disk read write head can directly access, fast, efficiently access. Okay, right? So here that is mentioned here. FAT and root directory reside at the fixed location of the volume. so that the system boot files can correctly located. Then quickly the read write head can move to that location and access that file and send it to the main memory. Okay, NTFS, new technology file system, is a proprietary file system developed by Microsoft. This improvement of FAT. So now they have done some modification to the FAT file. Okay, so normally when we consider about the FAT, there are two types, FAT16 and FAT32. Now here NTFS. Okay, so we can discuss about the number of characters that we can use to store the file, that as the file name. File name eකට කොච්චර characters දුන්නේ හැකිද කියන එක. Capacity of a file, කොච්චර capacity එකක් file එකට පාවිච්චි කරන්න පුළුවන්ද කියන එක. So the facility to compress the file. Now in fact 32 or fact 16 you can't compress the file, but in NTFS you can compress the file. And how you can use the Unicode. Okay, and capacity of the partition, when you consider about the FAT 16 and 32, less file partition capacity, but in NTFS large file capacity for a partition. Okay, so we will see here. This improvement includes the capacity to recover from some disk related error automatically, which FAT cannot. So the NTFS can directly attend to the errors happen in the disk and automatically fix them. But here FAT can't do that. File allocation table can't do that. Support with Unicode encoding systems. Now FAT 16 and FAT 32 can't go with the Unicode, but NTFS support into the Unicode systems. Improvement support for large hard disks. So NTFS support for large capacity hard disk. Better security, as permissions and encryptions are used to restrict access to specific files to approved users. So here mainly discuss about the file permission security. So as I have showed in the previous slide, how the administrator has got the permission and how the user has got the permission. So like that we can do the necessary restrictions and encryption part. File security. So now we have discussed what is a file and what we can do for the file, how you can retrieve the file. Then the main thing that you have to know, how you can protect your files in the computer. When you are protecting, here I have discussed two main methods, passwords and the access privileges. Right? So authentication. What is authentication? When you give the username and the password, the system will check whether the username and the passwords are correct. Then it will give the authority to you to do the modification or whatever the permission that you are having. According to that, you can access the file. Authentication refers to identify each user of the system and associating the executing programs with those users. It is the responsibility of the operating system to create protection system which ensure that a user who is running a particular program is authentic. Operating systems generally authenticates user using the following ways: with the help of the username and with the help of fingerprint, eye retina patterns and the signature. Okay, user needs to pass his/her attributes via designated input device used by operating system to log into the system. And the username and password, as we know, we have to type the username and the password, then it will allow to use the system. File allocation method. So when you consider about the file allocation method, the allocation methods define how the files are stored in the disk blocks. Okay, so how you can store whatever the files that you have created in the computer hard disk. So without knowing what will happen, the operating system uses these methods and storing the files. Right, it is hidden from the user. So what will happen? The user is using the user interface. graphical user interface with the facilities Vim, Windows icon, menus and pointers. He is doing whatever the things that he wants. He is using application software MS Word and typing a letter. File save, he is giving a file name and save. What will happen? This Word file stored in the computer hard disk, wherever you have selected, you are using file, save as, you are using D drive, and you are creating a folder, new Word document, and you are giving the file name letter.letter and save. But with the operating system, it automatically, the Word application giving the extension to the Word document docx, and with the help of the operating system it will store wherever you want. Okay, but when you are storing, there are three main methods used. File allocation methods. So what are these file allocation methods? Continuous allocation, linked allocation and index allocation. So these are the three main methods. So in our syllabus we are discussing about these three. The main idea behind these methods is to provide efficient disk space utilization. So when you are using the hard disk space means money. Okay, so the space we have to manage. When you are using the file according to file capacity, think about a video file, think about the capacity of that. So how you can store that? So when you are storing, you have to manage the space. Okay, so fast access to the file blocks. So when you have stored the video file, whenever you want, you have to access that thing really fast. When you have accessed, half is working, the other half is not working. Okay, or the video is not playing properly. Okay, it will take some time to load. Okay, so we have to manage that. So that managing part is done by the operating system. So when the operating system uses, it can use either method from this continuous method or continuous allocation or linked allocation or index allocation. All three methods have their own advantages and disadvantages as discussed below. So here we are going to discuss about the contiguous allocation. Contiguous allocation I'll take like continuous allocation. Okay, in this scheme each file copies a contiguous set of blocks. Contiguous set of blocks means the near, okay, right, adjacent, near blocks. Okay, near blocks, block collection of sector. It can be one sector or either more than one sector block where the operating system can access directly. Set of blocks on the disk. For example, if a file requires n blocks, now you are having a file, the capacity of the file is 750 bytes. A block has two sectors. Okay, block has two sectors. So block means the cluster. So one sector is fully filled, and from the other sector half of that will be filled. Okay, file required n blocks, and if the given block B as the starting location is B, then the blocks assigned to the file will be B, B plus 1, B plus 2, B plus n minus 1. Why we required n blocks? We have started with B, so it is ending with B plus n minus 1. Okay, so adjacent, nearest blocks. So in contiguous allocation, they are using nearest blocks to store the file. This means that it given the starting block address and the length of the file. Starting block ka B, length ka n. Okay, starting block is B and the length is n. So now the operating system can figure it out how it has to store the file. the directory entry for a file with contiguous allocation contains address of starting block. So they have given the starting block address, length of the allocated portion, the file mail. Now we are having a file called mail. Okay, the name of the file is mail. In the following figure, start from the block 19. So they are starting from block 19 with the length of 6. So that means it is starting with 19. So what will happen? There are 6. Okay, so 19, block 19, we are starting from block 19, no? 19, 20, 21, 22, 23, 24. 1, 2, 3, 4, 5, 6. 6 nearest blocks, adjacent blocks are taken to store the file mail. So we will explain this thing with the help of the diagram. So here you have the diagram. This is the directory. This is the directory. So the files you have stored under this directory, file names are here, starting blocks are here, and the length display here. So now you can see count starting from 0 to length. So starting from 0, this is continuous allocation. Because of that, how many number of blocks required? 2. So 0 and 1. So see, okay, TR starting from 40th location. So these blocks are already numbered. So what will happen? The read write head has to move to start the TR file with 14. So 14, how many number of length blocks are there? 3 blocks, 14, 15 and 16. 14, 15 and 16. So you can see here 14, 15, 16. When you consider about the mail starting from 19, how many blocks? 6 required. 19, 20, 21, 22, 23, 24. So you can see that. Okay. Now here you just think, if you want to do the modification for this TR and required another 3 blocks, can you take that? 14, now it is start from 16 and you have done a modification, you have insert an image and a video to this one, so another 3 blocks required, so it will be little bit hard, no? So here there's no enough blocks, continuous blocks. So it is a disadvantage in this continuous allocation. So now you can see, so each and every memory locations are numbered, and when you are storing, you have to give the file name and the starting location and number of blocks that you require. So what will happen? Automatically the operating system starting from that location and assigning whatever the file capacity that is required. Now when you consider about the features of this contiguous allocation, simple, easy access, file size is not known at the time of creation, extending the file size is difficult. As I said here, extending file size is difficult. External fragmentation, external fragmentations available here. Why? So many wastage. So you have given 0 and 1. Now you want 5 blocks to store another file. So 2, 3, 4, 5 can't store here. So it has to go to another location. Here 8, 9, 10, 11, 12. Can take this one. Okay, 8, 9, 10, 11, 12. Okay, can take this 5 blocks. But if it is required 7, so from where it can find out. So some wastages are there. External fragmentations. Free unusable space between allocations. So allocate kala thiyena metana free spaces thiyena, but they can't use that. So that is we are calling as external fragmentations. Okay, so this is the simple way, and you can access the files really fast. Okay, so it is sequence, one after the other, one after the other, sequence one after the other. First you have to access the zeroth block, then you have to move to the first block, then you can access that. Okay, we'll move to the next one. So advantages and disadvantages I have given here. Both sequential and direct access are supported by this. For direct access, the address of the k block of the file they have given. Remember, mainly in our syllabus you just write this can access sequential. This is supporting for sequential access. Don't write about the direct. Okay, right? This is extremely fast since the number of 6 are minimal because of contiguous allocation of file block. This is extremely fast since the number of 6 are minimal because of the continuous allocation of file block. So you can, if you can read the first block, then the whole file you can read because it is displaying like continuous. Disadvantage: this method suffers from both internal and external fragmentation, as we have discussed. After you have given some allocation, if you want to put another file, so with the available space sometimes you can't go, so because of that the fragmentations are there. This make it inefficient in the terms of memory utilization. So the memory allocate karne gatot dekama, this is insufficient. Increasing file size difficult because the dependent of the availability of the continuous memory locations. So when you are going to do a modifications to the file, if there's no enough blocks, it will be difficult. Okay, right? So that thing is there. I'll take the automatic linked list allocation. This is the second method, linked list allocation. In this scheme, each file is linked list of disk blocks which need not to be continuous. So here you don't need to store, or the operating system is not using the nearest blocks to store the file. The disk blocks can be scattered anywhere on the disk. So here the blocks can be here and there. It doesn't matter. The operating system can find out where the files are, how the file has stored, and there's a linked list. Linked list means one block to another block, there's a link. So that link is identified by the operating system, and it will give the instructions to the read-write head how to read the file. The directory entry contains a pointer. Now here you can see there's a pointer. With the help of the point only it can start to the starting and the ending of the file block. Okay, there's a pointer. Each block contains a pointer to the next block occupied. So you will have to remember. Okay, now when you consider about this, pointers are used. Okay, pointers are used to identify each and every block. Okay, each block contains a pointer to the next block occupied. So what will happen? Each and everything are linked together with the help of this block. Okay, so starting block and the ending blocks are there. So that is stored in the file. When you go to that file, it will direct how you have to move to each and every block with the help of the pointers and read whatever the file that you require. The zip file. Now you are having a file named zip. In the following image shows how the blocks are randomly distributed. Randomly means here and there. In the hard disk, here and there the file can be distributed. The last block 25. The block number 25, okay, contain -1, indicating null pointer. So that point onwards you don't have any memory location, storage location to move, and does not point to any other block. Does not point to any other block. That is the ending point. Okay, right. We'll go to the next one. So linked allocation, each file a linked list of blocks. File ends at nil pointer. No external fragmentation. Just to remind you, there's no external fragmentation. Now when you in the exam they can ask compare contiguous allocation and the linked allocation. So here you don't have any external fragmentation. Each block contains pointer to the next block. No compaction, external fragmentation. Free space management system call when the new block need. So available things are there. Now in the contiguous allocation there's external fragmentation, and when you want to increase the size of the file, what will happen? It has to search for the continuous block, but here it doesn't affect. Why? You can go to any with the help of a pointer you can identify. Improve efficiency by clustering blocks into groups, but increase internal fragmentation. So here the internal fragmentations are there. Reliability can be a problem. Now there's a problem. What is the problem? Reliability. Why? Now think, all the files are linked together. What will happen? There's a bad sector. In between the file, there's a bad sector, right? Where we have stored a pointer where the pointer is there. So there's a bad sector. So what will happen? The link will be the link is not available. Why? There's a bad sector. So because of that, the other files can't access. So there's a reliability problem. Locating block can take many input output disk 6. So that is there. So here you have shown your how a block is there. So the block and the pointer and whatever the data available, whatever the file contain is there. Okay, with the help of the pointer you can link to other pointers and you can load the file. Now here that zip, okay, zip file. So starting from 1, okay, file zip. So in the directory it has stored the zip file starting from 9. So 9th block. So you're having 0, 1, 2, 3, 4, 5. The blocks are there. So 9th block you are starting 1. You are going to the 16th block. You are moving to the first block. You are moving to the 10th block. You are moving to the 25th block. That is the end, nil point. So from that location onwards, you don't want to go here and there. Okay. So with the help of this file allocation table, what will happen? The operating system store the file and the starting point and the ending point will be known, and in between the link is there. So with the help of the pointers, so you are linking, and here the nil point. So the file is finished in from that. So as I said, because of the bad sectors, the bad sector has affected to this block 1. So what will happen? Here you have a bad sector. Okay, here you have a bad sector. So what will happen? This can't access. So when it is moving to the block number 1, there's no pointer to access the second location. So there's a reliability problem. So remember about that. So features: no external fragmentation, file can grow easily. So that means if you want to increase, you can give a pointer and you can connect with another location. So that means increasing is easy. Many seeks are required to access the file. So to access the file, you have to move here and there till the nil point is there. Okay. MS-DOS fact file system example they have given. MS-DOS fact file system. Okay. Advantages: this is very flexible in the terms of file size. File size can be increased easily since the system does not have to look for contiguous chunk of memory. This method does not suffer from external fragmentation. This makes it relatively better in terms of memory utilization. Disadvantages: because of the file blocks are distributed randomly on the disk, a large number of seeks are needed to access every block individually. This makes linked allocation slower. Main point is what? Here this is making the linked allocation is slower. Okay, large number of seeks are there. Okay, it does not support random or direct access. We cannot directly access the block of files. Why? We cannot access the files directly. Okay, it is going sequential access is there. So in linked you are using sequential access from the starting block or from the via block pointers. Pointers required in the linked allocation incur some extra overhead. Pointer it will allocate some space. Okay, linked allocation incur some extra overhead. We'll move to the next one. Index allocation, third one, the last point. In this scheme, a special block known as index block contains the pointer to all the blocks occupied by a file. Index block contain. Okay, each file has its own index block. The I entry in the index, I means a block. Okay, index block contain the disk address of ith file block. The directory entry contains the address of index block as known as in the image. So here you have directory file zip index block 19. So in 19 block all the details are there how to take this file zip. So this is randomly here and there it has stored, but in index block 19 it has all the details how you have to access the image file zip. Features: file ends at nil pointer. So files end at nil pointer. So when you are accessing here, the many locations has given, all the addresses, all the pointers are stored here. So with the nil pointer, the file ends. No external fragmentation, as we have discussed in the contiguous allocation. Here we don't want to use the continuous ones, randomly we have stored, so there's no external fragmentation. Each block contains pointer to next block. Each block contains pointer to next block. No compression, external fragmentation. Advantages: this supports direct access to the blocks occupied by the file and therefore provide fast access to the file blocks. So remember what this provide fast access to the file block. It overcomes the problem external fragmentation also not there. The pointer overheads. The pointer overhead of index allocation is greater than the link allocation. Why? The 19 block needs to keep all the details about the other blocks, and other blocks also need to keep where they are linking. For very small file, say file that expand only 2-3 blocks, so you are having only 2 blocks file, but for that also you have to keep the index allocation, would keep entire block. So it will keep one entire block to keep all the details about the pointers, which is inefficient term in memory utilization. However, in linked allocation, one pointer is therefore the block. Okay, one pointer, lose the space of only one pointer, one block. Okay, right. So this is all about the file allocation. We have discussed 3 file allocation methods: contiguous allocation, linked allocation, and the index allocation. Just go through these things. So when you are going through this presentation, take a paper and a pen, write down whatever the important things. So I am going to give some questions, but before you are doing the questions, you have to go through the video. Okay, so here many important things we have discussed. These things are coming for the exam. Okay, so because of that, study hard. If you have any doubts, I'll give 2 days, just go through, and if you have any doubts, you just send whatever things that you can't understand, then I will again explain with more examples. Okay, thanks for watching the video. If you have any doubts, you can send it to my email address, or you can directly contact my telephone number. Here you have given where you have taken the resources. Okay, mostly I have used the teacher's guide, ICT A level syllabus. Thank you.